Greetings from the surface of Pluto. It's cold here, but I should be able to solve this problem before I expire. So, let's get to it. Total current is what we want in this circuit. It's series, so once we find this current, we'll know the current through every component in this circuit. The total current can be computed using Ohm's law and rearranging it slightly like this. We know what the total voltage is, or we should, because we have two batteries, both of 6 volts, that are pushing current in the same direction, which is this one, right? So, we can add their voltages to find the numerator of this, and total resistance when we have series resistances is just the sum of the individual resistors. So we have a 10, a 20, and a 40 ohm resistor in this circuit. Once we sum all of those up, we have 12 volts divided by 70 ohms, which gives us just under 0.2 of an amp of total current. Done. Okay. Now, the next one we want to know is what the voltage drop across resistor 2 is. Okay. So resistor 2 right there. Well, all we really need to know to figure that out is the current through that second resistor and the resistance of that second resistor. But we know these things, right? We know that the current everywhere in this circuit is just the total current. It's present at every point in a series circuit. And R2 is known to us, right? It's 20 ohms. So once we put in the total current and multiply these things out, we will get about 3.5 volts, if I'm not mistaken. Done. Now C, voltmeter reading from open dot to closed dot. So that's looking here, and it's looking here. Okay. Now, we can solve that pretty easily because we know what the current through both R2 and R3 is. And if we sum up the voltage drops of R2 and R3, then we know what the voltage difference is from just before R2, so right there where we want, to just after R3, right there at the closed dot where we want. So the voltmeter reading can be computed in the following manner. V23, so the voltage drop across both the second and third resistor, is I23 times R23, which is just I total, and this is the sum of R2 and R3 because they are in series. And we know all the numbers here, so we can put in our current. We can put in our resistances, which is 20 and 40 ohms, and then we can multiply that all together to get ourselves 10.3 volts or thereabouts. Okay. In terms of ballpark checking that, well, 10.3 ohms represents most of the voltage applied to the circuit. Remember that the total was 12 up here. Okay. And these two resistors represent the majority of the resistance in this circuit, so it makes sense that they would drop most of that 12 volts as you move around the circuit. Okay, that's the problem. See you later.